In this paper, I'm going to talk about the design process, a visual model. You can find it in the Git repository for this class, and my recommendation is that you read it before you watch the video because there will be a quiz. The process in this paper is a general engineering process that's not specific to a particular engineering discipline or a particular project. Her goal was to give the basic tenets of what an engineering process should be and to fit it on one page so that people could see the process as a single united thing. This is her process, and I understand that you cannot read it in this video, but the good news is you have the paper, so pull out the picture and look at it while I'm talking. The first thing to notice is even though this process initially looks linear, see all of those back arrows in the diagram at the top? That shows that engineering is really an iterative process. For each step in the process, she has given a procedure, which is not really a procedure. It really is what is the point of this step. And then she's given you some possible things for what the output or deliverable from what that step could be. And then she's given a suggestion of possible tools, techniques, and methods. I think that there are a whole lot of tools, techniques, and methods that are going to be very specific to your discipline or the problem that you're solving. But I think what she was really getting at here is what are the kinds of things you're trying to do during that step of the process. The next thing to notice is that she's used the same kind of step multiple times. So you can see multiple places where testing is done and multiple places where essentially a new solution is done. I think she has put these explicitly in the process because engineering is an iterative process, even more so than the back edges in a picture would show. So if you were going to show this to a non-engineering person, they would understand that we intend to do things multiple times because when we do it, we test it and we learn from that experience, and that allows us to make a better solution. The next thing to notice is that she's divided the process into three main categories, and I think she's done this because the way you're thinking about the problem is different in those different categories. And it's not that you don't iterate between them, because there are back arrows between them, but it's that you're thinking about what you're doing very differently. The first main category is understand, and the purpose of this part of the process is to make sure that you really understand what it is that you're trying to accomplish and what are the criteria for knowing whether you have accomplished it or not. The second main category is envisage, and in this you're trying to figure out what possible solutions are. And she makes a distinction between idea generation, which she calls a divergent process, and during idea generation you're trying to generate as many possible solutions as you can, and that's why it is a divergent process. And then in selection, you try to narrow those choices down to the few or the one that are most likely to succeed, and that is a convergent process because the options become narrower. The third main category is develop, and this is actually the part that we've spent most of our time trying to teach you how to do. This is where you're actually building the solution. That isn't to say that develop is more important than understand or envisage. And in fact, in real life, if you don't do the understand part and the envisage part, then the odds of you developing a good solution to your particular problem are pretty slim. So it looks like the development part of this is kind of iterations between prototype and test. Unfortunately, that gives the idea that prototypes are going to become the solutions. When in fact, a lot of times the reason that you build a prototype is because you're going to learn something. And so a lot of times prototypes are not the best solution. So one strategy to try to convince the world not to plan to use prototypes is to specifically call them throwaway prototypes. Make explicit the choice that you are doing this for the purpose of learning something, and that when you are finished, you will throw it away and use the knowledge to develop a real, better solution. So obviously, I don't think this is the perfect process, but that doesn't mean that the visualization is not a good thing. There's lots of really interesting and important information in that picture. And when we are trying to think about what is the best process for our particular project, you have to pay attention to not only things like this that other people have developed, but also the skills of the people on your team, the environment in which you are working, what are the company's requirements for process, and the particular technology that you're using. So there are lots of things that go into figuring out what is the best process for your particular situation. And part of how you do that is you look at lots of other things that people have said about what a process should be.